All right, guys, so real quick, let's go over just briefly scientific notation one more time, okay? All right, so when we look at scientific notation, you're going to be taking large numbers like, let's see, 1,320,000 and making them into numbers that are just a little more easier to manage, okay? So the goal of scientific notation is to have one digit between 1 and 9 in front of the decimal. So right now, because there's no decimal shown, it's at the very, very end. And what we want is we want our decimal to end up here between this 1 and the 3. That gives us that one digit in front of the decimal. So what we're going to do is we're going to take this decimal and we're going to count how many spots we have to move it. So 1, 2, 3, 4, 5, 6. So we're moving it 6 spots. So my answer, or this number in scientific notation, is 1.32 times 10 to the 6th. Okay. Now, one thing that often messes students up is this exponent. Now, we understand where we get this number from, but the question is this exponent going to be negative or positive? Okay, the way that I tell my students that I remember it is when the number is written out in standard notation, like it is right now, over here, if it is a large number, if it appears to be a really large number, which this does, and it appears to be larger than our number over here, then it's going to be a positive exponent. Now, I say appears to be larger because technically they are the same number. But this number over to our left does appear larger than this number over here to the right. And so therefore it's going to be a positive exponent. Now let's say if we were going to go from, let's make sure we keep that comma, from 0.020400, and let's say we're going to put this into scientific notation. So remember our decimals here, and we have the same idea. We want it to be right here. We want one number in front of the decimal, and that number needs to be between 1 and 9. Okay, so our answer is going to be 2.04 times 10 to the, now we moved it twice, so 2 times. Now the difference here is if you look at the number as it was written in standard notation, it appears to be a really, really little number compared to how it's written now. So since it's going to be that, since it was that really, really little number, that's going to mean it's going to be our negative exponent. Okay, so let's try a couple more. Let's say we have 0.000079. Okay, and we want to put this in scientific notation. So right off the bat, this looks like a little number. So I know my exponent's going to be negative. Okay, so it's going to be 1, 2, 3, 4, 5. So this is going to be 7.9 times 10 to the 5th. But again, we said it was little when it was written out. So it's going to be negative 5. If we do another long one, let's say 720, and let's put this in scientific notation. So again, if a decimal is not given, we have to say that it's at the end. But if it is given, you use it where it's at. So we're going to go 1, 2. So this answer is going to be 7.2 times 10 to the 2nd. So again, we only moved it twice, and this number in the beginning is a larger number than the number, appears to be a larger number than this number at the end. So it would be a positive exponent. Now, if you were given a number in scientific notation, so let's say we had, we just did a 2. Let's say we have 4.72 times 10 to the negative 3. Now, this is really where the way that I think about the positives and negatives helps me not make careless mistakes. So this is a negative 3. So I know when my number is written in standard notation, that number needs to look like a smaller number, okay? And so in order for it to look like a smaller number, my decimal needs to go to the left, if my decimal went to the right, the number would look bigger. So my decimal is going to go to the left, and how many times is it going to the left? 3 times. So let's see, we've got 472, our decimal is here, and we're going to go 1, 2, 3 to the left. So my new decimal is going to be right here, and I'm going to add in zeros. So my answer is 0.00472. Okay, so let's say, yeah, let me rewrite it. So 0.00472. Let's say we had 1.2 times 10 to the 7th. Okay, so again, this is a positive exponent, so I know in the end my number needs to look larger. So if my number is going to look larger, the decimal needs to go back. Okay, so I've got 1.2 and it needs to go back 7 times. Oh, I'm going to need more room than that. 0.2. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. My decimal is going to be here. And every spot that has the little place, I'm going to add a 0. So my answer here has 6 zeros. Okay, so 12 million. Okay, so I hope that helps, guys. Just a quick review of scientific notation. When we are calculating with scientific notation, let's say we have 1.2 times 10 to the negative 2 over 7.5 times 10 to the negative 4. Make sure you try to put this in a calculator. Make sure you know how to, because this little guy on the bottom has got to be in parentheses. If he's not in parentheses, your answer is not going to be right, okay? If he's not in parentheses, your answer is not going to be right. So let's see. So my answer is, we got 1.2 times 10 to the 0.2 times 10 to the negative 2 divided by 7.5 times 10 to the negative 4. And my answer is actually 16. Okay, so try it, plug it into the calculator, make sure you can do it. We are also going to have problems where we multiply them together. So like, so let's say like 6.2 times 10 to the 3rd times 1.3 times 10 to the 6th. Okay, but we don't tend to make as careless errors on this. But we do need to make sure we know how to put the scientifically noted answer in. Let's see, I got a really, really long number because mine didn't automatically put it in scientific notation. Let's see. 1, 2, 3, 4, 5, 6, 7 with 7 zeros. 1, 2, 3, 4. Now I am going to put this in scientific notation just for, I don't know, for the fun of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer in scientific notation is 8.06 times 10 to the 9th. Remember, it's going to be a positive exponent because, again, this was written out as a really large number. So, again, guys, I hope this helps a little bit. If you needed a quick review, if you have any questions, let me know.